Welcome to the FOSDEM 2017 Distribution Dev Room. We have Matthew Queen and Heiko Kumar here to talk to us about RTO's continuous packaging platform.
Good afternoon, everybody.
Wait, microphone.
Okay.
You're going to need, sorry, I forgot to tell them, it's my fault. You can, yeah, perfect.
Like this. Okay, so I'm Mathieu Huin. There's not much time, so we'll go fast on some stuff. Hopefully there will be, well, keep it like that. We'll have time for questions later. If not, I think I'm the only guy with a red cap around here, so you can find me easily. So let's get with the basics first, out of the way. If you don't know what RDO is, it stands for the RPM distribution of OpenStack. And if you don't know what OpenStack is, it's a collection of software that lets you install and administrate cloud infrastructures on conventional hardware. RDO is also a big community of users of OpenStack, of package maintainers as well, administrators and so on. And their goal in life is to help you install your own OpenStack infrastructure. The maintainers of packages maintain about 250 packages at the moment, and it's growing. So what do we need to build a package? Basically, it's going to be a very high level. First, you need the sources, obviously, of the software that you want to package. We'll call that the upstream code in the remainder of the presentation. And the next component of the package is called a spec file, or spec files if you have more. Basically, it contains the building steps of how to build the software from the sources, how to install it, how to remove it, the dependencies that it needs to work on your system, the patches eventually, if you need to adapt it to your system, and so on. So from that, we can infer that the job of a packager is pretty much the same as the job of an open source developer. A packager will need some form of version control. In the Fedora and CentOS universe, we call the spec file repository the dist-git repository. It has to be on a public platform because it has to be open to the community and to reviews as well. You want also to make sure that the contributions that you get are of the utmost quality, so you need automated testing and validation. So basically you need continuous integration on it. And your testing environment has to be controlled, and so the tests are reproducible. And you have high confidence in their results. You also need a smart merging strategy. If you have a lot of contributions that come at the same time, you have to make sure that when you merge them, you're not going to end up in a state of your master that you don't really know. But when you're a packager, you also have a specific constraint, which is upstream. You have to follow what's going on upstream. You have to make sure that your spec files evolve if upstream evolves. And you want to release as early as possible after a change occurring upstream, especially if the change is a vulnerability fix or security fixes. And when you package OpenStack, it's even more complex due to the sheer size of the project. OpenStack represents more than 600 projects for the last cycle. Every 6 months there's a release. The last cycle was called Newton. So in the last 6 months, there were more than 600 projects, about 240 commits a day, which is humongous. Just for Nova alone, which is a compute component, we had more than 1,700 commits, which is about 10 commits a day. And during the stabilization phase, which is about 1 month before the release, it ramped up to about 280 commits a day. So what does this mean for OpenStack packagers in the RDO community? It means that you have to make sure that the spec file is validated after against each change, because if you wait for 1,700 commits, you're going to have a bad time. So you can do that at the last minute. Also, you need to be aware of the strong dependencies between the softwares in the OpenStack suite, because if Nova changes, it's going to impact all the other projects. So,
can you just explain what is Nova?
It's the compute component for OpenStack. So if you have a change on Nova, it's going to affect everything. So you have to test again all your other packages to make sure it's still working. And the test platform must also be able to absorb huge spikes in activity. So now that we know what the problems are, let's look at the tools that we have at hand to build an RPM factory. So first, let's look at what the RDO community came up with. The main tool I'm going to talk about, I'm going to be fast on this. If you have questions, just ask us after the presentation. The first one I want to talk about is called DeLorean, like the car in Back to the Future, because it basically builds packages from the future. It looks at what's happening upstream, and when there's a change, it's going to try to build a package using the new changes in upstream. It also acts as a master RPM repository because it uses the latest source code from upstream. And if you want to know more, there's an article linked on the presentation. We're also going to use a CLI, a command line interface called RDO PKG, which will help with basic tasks needed for a maintainer, especially flattening patch chains that have to be included in the spec file. We'll talk about that more when Heikel talks about the use cases. Next, let's talk about community tools. The CentOS and Fedora community use a tool called Koji. Koji is basically a client and server architecture that lets you build and store RPM packages. So you can use your own instance of Koji, but you can also use the community build system, which is an instance of Koji that has been set up by the CentOS community. And you can build, if you, well, you have to set up communication with the CentOS community first, but you can use it to build your packages on it and test them. And the last piece of software that we're going to use is called Software Factory. This is basically a software forge, which includes a CI/CD platform. And the specificity of it is that it's inspired by what OpenStack is doing for their own CI that we call Infra. So it uses basically the same tools that you might know, like Gerrit for code review and Jenkins for testing, for jobs automation, but also some tools that that are not that known because they are developed by the OpenStack infrastructure, like Nodepool, which is a service that provides job nodes on demand, and Zool, which is kind of a release manager and also a job orchestrator. So I'll go fast on the features that Software Factory provides. It's really cool for development, not just packaging. So you have code hosting and review through Gerrit. You have job orchestration through Zool and Jenkins, as I said. You have also Zool has a nice feature, which is project dependencies management. When you build a test environment, it will build it taking care of those dependencies by itself. So Nodepool allows you to build, to use jobs, nodes, and slaves on demand whenever you need them. You have a smart commit gating as well. So I'll go faster. The config is managed as code, so you can also use a CI workflow on it. And you have a flexible workflow, so that's why you're going to use it for RDO. So with all that, sorry, there's not much time, so we have to go fast. So with all that, we managed to create a RPM factory. So basically, upstream changes are going to be taken care of by DeLorean. And the tests are going to be taken care of by Software Factory. The workflow is going to be managed by Software Factory. And all the building part is going to be taken care of by CBS, by the community build system. So this is a workflow overview. I believe that the presentation has to include a very complex workflow diagram that we're not going to explain because it means that we're doing some serious business. But basically what I want you to remember from that is that we're going to use 3 different kinds of repositories. We're going to work with upstream, with the RDO dist-git, which is the spec files repository, and also a repository for patches that we're going to include in the dist-git. And I will let Heikel talk to you about the use cases that we cover with this architecture.
Thanks, Matthew. Okay. Okay, just hold it like this. Okay, I'm Heikel, I'm the weird guy sitting here. I'm here because I'm the RDO release wrangler, so I'm the first user, so here to explain you the use cases. So we have 3 main use cases. The first one is packaging master branch, as Matthew said. So we take sources from upstream, like for instance the Nova sources, and then we take the packaging sources, and then we use DeLorean, take both repository and try to generate an archive of the sources and then generate the package using the spec file. It has also some magic to generate proper versioning and stuff like that. And after that, we have 2 possibilities. The package bus. everything is fine. Well, mostly. Because you could have item change that are not catch up, but that's our job for two packagers to fix that. It fails. So what will it do? So if it fails, usually it's because sources have changed, or we have missing dependencies or stuff like that. So we need human intervention here. So we create a placeholder review in Garrett as a way to say, hey, maintainer, we need your attention to fix that point. You have the build logs showing you what's the problems, please fix it. And the thing is, since we're using Garrett, it's public. So anyone can see the failure and fix it. And the maintainer will be able to review your patch and fix it for you and merge it. So it also helps to lower the entry barrier to packaging. So next step, well, also we're tracking stable branches. So rather than waiting that upstream makes a release, we just say, hey, let's track stable branches, do as we do with master branch and package every commit and see if anything changes. Usually it just works for stable branches, at least for OpenStack. But the thing is, we run CI and we can detect CI failures early and fix them. Usually it's mostly we have to change dependencies, or we have a dependency that was updated and broke things. So what does it do? Two things. Since we are sharing branches between stable branching, striking, and release and actual releases, it detects if we change name and the version manually. So it will do a scratch build on CentOS build system. So we see if it builds, and if it succeeds and the maintainers approve the change, it will do the final build for you, and it will get exported to CentOS repositories. Well, the thing is, we get to control who has access to build system like this, and it helps lowering the entry barrier because you don't have to grant build system access to everyone. So currently for CentOS Cloud SIG, we only have 2 or 3 people with access to the build system, but we have much more people doing the builds through Garrett. So this is the same thing. So if it fails, you still need to have the maintainer come on and fix the patch, but it doesn't get merged. The third case is when we have distro changes. For instance, you have a user reporting a bug with systemd services, so, which are something that are not always tested. So it's a distro specific change. So you do the change, and it, as a previous use case, it will get built in CentOS build system and like that. You also have another category of patch, which are changes, distro specific changes, which are downstream patches. Well, in RDO use case, we try to limit the number of downstream only patch. So what we do is we have a repository tracking upstream sources, and we manage downstream patches as open review in Garrett. So if you know Garrett, usually when you add patch, it gets merged, but in this specific case, it doesn't get merged. This allows us to track the downstream patches history across the releases, because we keep updating the tracking upstream tracking repository, and our patches are just a set of reviews, and Garrett will detect if they need to be rebased or if we have rebase issues. So when you can just rebase, it can do it for you automatically if you configure Garrett to do automatic rebase. If you don't, and you have failure, you just have to retrieve the repository, retrieve the review code. So the RDO packaging tool will simplify that for you, and then you just do your manual rebase and update the existing reviews. So it simplifies maintaining downstream reviews. As a packager for two distribution, CentOS and Fedora, I had experience with managing downstream patches, and the biggest issue is simplifying collaborative work across patches. So different packager have used different tools and they work sometimes on the same page. Here we have only one, Garrett and get, period. So it makes it simpler. Okay, so return on experience. So for RDO, we're in the Okata cycle, Okata being the next OpenStack release, which will happen around February 20th. So we have numbers for the previous cycle, which is Newton. We had about 800 commits from 70 contributors. So my team at Red Hat is about 7 person, and not all of them are doing packaging. So that shows that we have multiple people outside the RDO team helping on the packaging. So mostly people outside Red Hat and few Red Hatters. We also code through DeLorean in master branch about 230 build failure. So it's about 1.5 build failure per day, but it's not. We don't have build failure every day. It's mostly about early in the cycle or during just before release candidates. So we can get for 2 weeks no build failure, and just before the release candidate we can get 30 build failure at once. But it allows us to detect build issue early. When we get, for instance, and I'm coming here, RDO Newton packages were available in CentOS repository 10 hours after the upstream general announcement. And why? Because when the announcement was made, all our packaging was ready. We had CI jobs that was already running against that code because it got frozen at some point. What we had to do was just pushing the final tags in packaging repo, running CI jobs, generating final repositories, and also updating documentation or own announcement, and that's all. So that's quite fast, because the usual process for distribution is wait for the announcement, retrieve the table, try to build the thing. If it fails, fix it. So just imagine for OpenStack, which is about 400 packages, and I'm not even counting the dependencies. So if you're trying to do that, it takes like 2 weeks at least to roll a release, and 2 weeks is very narrow to do that. So it's kind of successful to release faster and with higher quality, thanks to CI jobs running behind. So the return on experience was, we have automated the distribution pipeline, so it's like continuous delivery in practice. So we're following the OpenStack pipeline, integrating within the CentOS pipeline, release pipeline. We have still few things to automate, but it's mostly here. Oh, sorry. We leverage a collaborative work through Garrett and reviewing, so it has much advantage on over GitHub pull requests, but I think the same article that Matthew was pointing out earlier, I think.
Another
Yeah.
one, but
Oh, another one. Okay.
very different
Okay.
topics, so it's long, so
It.
just read it.
Okay. One of the issue when you start a new RPM or any packaging distribution is that building a community of contributors. Okay, let's be honest. Most OpenStack developers don't care about packaging. They don't want to learn about packaging. They don't want to learn about new process. So we are using a process that is much similar to the OpenStack one. They're using Garrett. We're using Garrett. We have the same concepts. And also anyone that is not familiar with packaging can start rolling up, because they can see through reviews how people are working, what they are changing in spec files and stuff. So it's kind of self-documenting process. So it makes it simpler, and you get code transparency, peer reviewing, and so on, faster onboarding. So if you want to join us, so if you want to implement that kind of process, you can look at softwarefactoryproject.io, which is the basis of the RPM Factory project. It is used by Software Factory itself, Distributed CI, which is a distributed CI for RPM distributions, Skydive, which is a network analysis engine.
Real-time network analyzer for
Yeah.
OpenStack as well.
Yeah, and also if you want to see a live instance, you also have review.rdioproject.org. That also 3 projects: RDO from the cloud, CentOS Cloud SIG, DeLorean project, and also OpTools, which is another CentOS SIG, providing operational tooling. And maybe your project, or maybe you want to build your instance. So if you want to keep in touch, well, softwarefactoryproject.io, also RDO project. On Freenode, you have the Software Factory channel. If you want to roll your instance, if you want to have feedback or help or want to know about OpenStack, we have the RDO channel. And also the mailing list of both projects. So feel free to ping us. Mathieu is MUin on RC. I'm number 80 on Freenode, so feel free to ping us or catch us in the lobby. So thank you for attending. All right. Okay.
Before we take any questions, since we made it pretty fast actually, so that's good. I just want to add something that I didn't have time to mention before about the way the workflow is implemented. We can look at the workflow diagram. One important thing that is added through Software Factory is that all the tests for CI are done before any actual merging. So that's a very different approach to what usually CI does, which because the CI tests are usually launched once some code is added to the code base. And because we are an open source project and we might have a lot of contributions, we want to make sure that the contributions are valid before we actually merge them. So not just a peer review, but also automated validation. So do you have any questions?
Is this workflow available on your webpage or?
It's on the RDO documentation. Yes?
The downstream patches and repos, have you considered using Git upstream?
It's complicated.
What about using?
The patches upstream?
Yeah.
Have you considered using it? Git upstream, it's a tool for managing.
Oh. No. We just.
Your current process and changes are kept open,
Yeah.
so they're not view those.
No, we have rolled our own tooling to flatten the patch in the packaging deskgit, because deskgit just store all of the downstream patches in the repo. So we don't need to have them inside a repository. We just need a tool to retrieve the flattened patches. So RDO packaging will connect to Gerrit, or it will see all the open reviews, and it will check if CI is passing. It will check also the voting, so you can have patches open, review open, but if they don't get the right votes, they are not included. So you can even remove a patch very fastly, and okay, I will just change my vote here to remove it, and it gets removed automatically for you. Okay, another question?
This will be last question.
Okay. Yeah.
Are you running your CI tests on every change that's landed in Nova, or do you?
We're trying. Actually, the thing is, we don't have enough capacity to run that, but we're retrieving changes from upstream every 5 minutes. So that's pretty much close, but sometimes we get 3 commits merged at the same time, and we just test them all together, but that's something we're working on, but I don't think we ever had more than 3 commit tested at once in practice. And by the way, I'm seeing RPM Factory contributors here, Sebastian, so if you can applaud him. I'm happy to see you. Okay. So everybody. Thank you.
And